Hi everyone, welcome back to my YouTube channel TechDataEngineer. So in this video I'll explain the concept related to Pyspark, that is the adaptive query execution. Okay. So in my last video I have explained what is Catalyst Optimizer, why we are using that. So in this video we will understand what is adaptive query execution. Um, Before understanding the formal definition, we will understand what is why AQE exists basically. So what was the problem with the earlier method? Why AQ exists? What exactly Spark changes at runtime? And then how AQE fixes skewness or performance issue? Then we'll explain the definitions of AQE and how it behaves in the real production. We will see with examples also. Okay. So I'll explain all these things related to that. Okay. So before understanding the actual definitions of adaptive query execution, we will understand the real problem, like why AQE was introduced. Okay, so before AQE, Spark worked like this. Okay, so if you see why AQE basically exists, so before AQE, so I'll explain the scenario here. So if you understand, okay, so this is, if you see before AQE, so what Spark does? So Spark Spark worked like first. So there are few steps like before AQE, like Spark guesses the data size. Okay, so Spark guesses the data size. Okay, data size. Then what I do? Second step we do like create a fixed execution plan. Okay, create create fixed execution plan. Okay, how it do in case of catalyst optimizer, similar thing, then it execute it exactly as planned. Okay, then third step it do execute it exactly as planned. Okay, so before AQE, Spark work like this one. Okay, so first step, Spark guesses the data size, create fixed execution plan, and then execute it exactly as it is planned. Okay, so what was the problem with this approach? Okay, so the problem was, what was the problem? What was the problem with this approach? Okay, so the problem was in case of Spark, guesses are often wrong in this approach. Okay, so why? Because if you see the example, so in this the problem was like whenever Spark guesses all these things like data size or any other approach like execution approach, so every time, so most of the time Spark guesses are often wrong. Why? Because suppose it estimated the data size, like it estimated the data size. Okay, it estimated the data size. Suppose data size equals to 10 GB. Okay, but when it do the execution, actual data size is found like a 300 MB. Okay, so estimated versus actual was wrong. Okay, so what was the issue because of that? So it uses, because it is estimating and it is using that approach, so that uses the merge join. Okay, that uses like merge join, or that create shuffle. Okay, shuffle partitions, and that so because of that there was a waste of CPU and memory time. Okay, so because it is estimating based on 10 GB and we are getting the actual data of 300 MB, so it is using merge join, it creates shuffle partitions, so because of it's a CPU waste and memory time waste also. Okay, So this was the region, because of that AQ introduced. So because of this problem, like because of the wrong estimations, so we are getting like a slow job. Okay, so first issue was slow job. Okay, this was the one of the problem. Okay, then the other problem was more shuffle. Okay, more shuffle, and then third problem was resource waste. Okay, resource waste. So these are the three problems, like slow job, more shuffle, and resource waste. Why this problem? Why this is happening? Because of the wrong estimations. Okay, so our actual estimation is different and estimated value is different. Okay, so because of this reason, AQ comes into picture. Okay, now we will go through the AQE definition. Okay, so what is AQE basically? Okay, so what is AQE? So AQE allow a Spark to change the query execution plan while the job is already running. Okay, so it is changing at the time of run. Okay, so that is called dynamic change. Okay, so AQE allows Spark to change the query execution plan while job is already running. Okay, so other definition we can see AQE optimized query using real runtime static instead of estimate. So in case of Catalyst, we are doing the estimations, but in case of AQE, we are estimating at runtime. That is called runtime statics. Okay, so that's why AQE is helpful while running the job. Okay, it gives the actual estimation, not the estimated one. Okay, so that is the difference between Catalyst and AQE. AQE give the runtime estimations, and Catalyst give the that is the planned. So this static executions. Okay, so this is the simple definition of AQE. Now moving forward, we will see how AQE basically work. Okay. So there are steps. Okay, I'll explain these steps. So so if you wanted to you wanted to use AQE, you have to do first thing, like you have to enable AQE in your code. Okay. So that is the configuration setting. You have to enable that. Okay. So that I'll explain later. So I'll explain here what is AQE, how AQE works basically. Okay. So the first step is start execution. Okay, start execution. Start execution. Okay, so Spark begin execution with the initial plan. Okay, so how ideally it is doing in Catalyst, it is doing the same. It is doing the start execution. So start execution, it is doing nothing. It is just it's begin the execution with the initial plan. Okay, then in step two, what it does basically? In step two, it do the collect runtime statics. Okay, it collect runtime statics. Okay, it collect the runtime static. Okay, so after shuffle stage, in case of while collecting the runtime statics, after shuffle stage completes, Spark now know what is the, so in runtime statics, what it collects? It collect first like actual actual data size. Okay, actual data size. What other things it calculate? It calculate the actual partition size. Okay, actual partition size. What other things else it store basically? Which partitions are skewed and which are not? Okay, so which partitions are skewed? Okay, so these are the information. It is basically calculating at the time of run. Okay, then what was the third? Okay, so this is basically calculating this all. Okay, so now we'll see the third step. So in third step, what basically it does? So in third step it does the, so because it got the actual plan, right? So in third step what it do, it re-optimize re-optimize the plan. Why it is re-optimizing? Because it got the actual data, not the estimated data. So it got the actual data. So if based on actual data, it is re-optimizing the plan. So Spark replans the remaining stage, like change the join strategy. So in this step, what it will do, it will basically change the join strategy. Other things it do like merge shuffle partitions. Okay. Third things it do like what they do like split skewed partitions. Okay, so these are the things it basically does when he got the estimations. Okay, the now the fourth step what is this basically, after that in fourth step what this does, it basically execute the optimized plan. So it got the re-optimized plan. Then fourth step it basically execute optimized plan. Okay, optimized plan. Okay, so Spark learn from the actual data and that adjusts itself. Okay, so that's why in step three it is re-optimizing the plan, and then in fourth step it is executing the actual plan. Okay, so these are the steps which basically like these are the steps by which AQE basically works. Okay, so these are the steps. If you are enabling the AQE, it will basically go through these are the steps. Okay, then next we will see what AQE can do. Okay, so adaptive query execution, what it can do. Okay, so these are the things I have listed out. First thing is it do the dynamic change strategy. Okay, so what AQ can do first is the dynamic change strategy. How it is doing, basically I'll explain with a simple example. Okay, so what was the problem without AQE? So first we will see without AQE, then we will see with AQE. Okay, so we'll see without without AQE. Okay, so without AQE. So without AQE, Spark chooses join strategy before execution because I have already explained above. So it is estimating the data size is like a 10 GB, and based on that it is doing the uh, join strategy. Okay, but when it is estimating the actual at the time of run, it is getting the data as a not the 10 GB, it is getting like a 300 MB. So without AQE, Spark chooses join strategy before execution. So what happened here? Sparks chooses join strategy before execution. Okay, before execution. Okay, and with AQE, what is do AQE? With AQE, what it does? So with AQE, Spark can change join type at runtime. Okay, so join type at runtime. Okay, at runtime. So that is the things. That is the different. So in above cases without AQE, it is using the it is using the like planned was suppose this was the plan, right? If you see the planned was like sort merge join. Okay, sort merge join. Okay, and if we see runtime runtime data is small. Okay, actually it is saying runtime data is small, then what it do? AQE switches to broadcast join. Okay, So initially it estimated and see the data was used, so that's why it was going through the normal join, merge join, and when it saw that data is small, so it is going through the broadcast join. Okay, so the result is no supple. So what is the result after that? So if it is using the broadcast, so in that case there is no shuffle. So what is the solutions we got? What is the benefit we got? First benefit we got like no shuffle. Okay, no shuffle. Second benefit we got like faster execution. Okay, faster exg faster execution. Okay, these two things happen. Okay. Now we'll understand the second problem. Second, now we'll understand the second what things AQ can do. The second thing is shuffle partitions college. Okay. So here also we will see problem without. So problem without AQE. Okay. So when EQ was not there, what was the problem? Okay. So whenever we are doing like a Spark dot SQL dot shuffle dot partition occurs to 200. Okay. So even if shuffle output is small, even if shuffle output is small, a Spark create partition as a 200. So this was the problem. Even if small shuffle output is small, a Spark creates 200 like 200 tasks because we are getting the 200 partition. So with AQE, so when AQE comes into picture, what it does basically. So with AQE, 1 minute, yeah. So that with AQE, what it does with AQE, what it does, it measure the shuffle output size. First, it will measure shuffle output size. Okay, and it reduce the task overhead. Okay, task overhead. So planned partitions was like so. Our planned partitions was 200. Now it reduced to AQE reduced to 20 partitions. Okay, okay. So this was the things we got. Okay. So before that, whenever doing spark.sql.shuffle partition, so it is creating into 200 partitions. Because of that, we are getting the 200 tasks. So with AQE, what is doing? It is measuring the shuffle output size, and based on that, it is doing the partitions. So suppose it is doing 20 partitions, 200 partitions to 20 partitions. It is reducing the partitions. So we are getting the measure shuffle output. We are getting the reducing the task, and the task overhead also we are getting reduced. Okay. Then the second is skewed join handling. Okay. The third things we are getting the what it can do is third thing is skewed join handling. We will see that. So in skewed join handling, so what AQ detects like one partitions much larger than other. Okay. So what AQ does basically so splitting the if we are getting like a large partitions. Okay. This is suppose large partitions. Okay. So if it is finding the large partition, it is basically splitting into different small partitions. Okay. So split large partitions into small chunks, run them in parallel, and prevent one big running task. Okay. So because of AQE, we are not getting like a job running at continuous at loop. Okay. So we have seen our previous video, we are getting like a out of memory issue, right? Out of memory issue or job stuck. Yes, job stuck 99%. Okay, it is running loop running, right? Uneven task running. So this was the problem handled by SQ join. Why? Because if it saw there is a large partition, it is splitting into different partitions, and because it is splitting into smaller partitions and running these tasks parallelly. Okay, so this was the solution with SQ join handling. Okay, then. Uh, Next thing we will see, enable AQE. Okay. So how to enable AQE? So in your configuration, so whenever like that is the I can say mm, ideal thing. Like whenever whatever the configuration you wanted to change in your Spark code, you need to create that a conf file. So different conf file. Don't You can change in your main driver code also, but the better or the convention is to you have to create a Spark file. Okay, and then in that file you have to change. So how to enable AQA basically? How we are enabling? We are enabling like we are enabling like a spark dot conf dot set. Then we are doing spark dot sql dot adaptive adaptive dot enabled. Then here assigning as a true. Okay. So spark dot conf dot set, a spark configuration set we are doing spark enabled and spark SQL adaptive enabled equals to true. Okay. And some other configurations also we are doing Spark SQL adaptive college partitions enabled equals to true, or a sparse SQL adaptive SQ join enabled equals to true. So you can go through the that Spark documentations. Okay. So you can go through the Spark doc and you can refer the AQE adaptive query execution, and you can see this code also, like how to enable AQ in your code, or you can Google it. Okay, whenever you are doing the actual thing. Okay, so you can go through that. There are multiple way you can enable and multiple configuration setting you can do that also. Okay. The next thing is how basically you can go through how to see it, like how to see that your plan is getting created. You are going through the actual plan, or you're going through the estimated plan only, or you're going through the runtime. So in Spark UI, go to Spark UI first. Go to Spark UI, then go to SQL tab. SQL tab. Okay. Go to SQL tab. Then you will see adaptive spark plan. Okay, you will see like adaptive spark plan tab. Okay, so then you'll see like adaptive plan is different from initial, adaptive plan is different from initial, or it is same. You can see that. So you have the option is go to Spark UI, go to SQL tab, and then you'll see the Spark SQL plan. Okay, so these are the steps. Here you can see that. Okay. Now the next question is what is AQE and what AQE versus catalyst? Okay, so so I'll explain here catalyst first. Okay, catalyst versus AQE. Okay, okay. So catalyst, what it does? It do the before execution, before execution. Here during execution, during execution. Then we have usage statics. Okay, usage statics here, uses runtime data, uses runtime data. Okay, the next thing is static plan. It is basically working on the static plan. Okay, static plan here, this basically working on the dynamic plan. Okay, dynamic plan. Okay, then next topic is when AQE help most. Okay, so when AQE help most, so AQE help if you are finding you have the SQ data, you are find your data is skewness, unknown data size, large join, variable daily data volume. So these are the scenario where AQ help most, okay, to your job. Okay. So I have given this scenario. Apart from this scenario, we have lot many scenarios also where I can see your AQ is helping here. Okay, so if our data set is very small, then there is a chance of overhead. So overhead is more than benefit. So we are not using with the small data set. But if your data set is skewed, unknown data sets, variable data daily volume or large join, so this is in this scenario it is helping. Then the next and last topic is AQE limitations. So what are the limitations of AQE? Okay, so this basically I'll give you the point. Okay, so first point is work based works based with with Spark SQL. Okay, yeah, data frame. S- First scenario is only work based with the Spark SQL or data frame, not in case of RDD. Okay, less effective, less effective, less effective with heavy UDF uses. Okay, and the third scenario is what is the third limitations? It require shuffle stage to collect. Okay, requires shuffle requires shuffle stage to collect states. Collect states. Okay, so basically AQE, you can say finally AQE adds slight overhead. Okay, AQ add slight overhead, but usually improve performance. Okay, but usually, so if your data size is small, in that case only it is adding the overhead. But most of the time you will see your performance will be performance will be significantly up. Okay, so there is a chance of overhead here. Okay, overhead, but performance if you'll see performance all the time it should be up only. Okay, significantly high compared to without AQE. Okay. So based on your strategy, data volume, data size, task, you can use this AQE in your job. Okay. Thank you. Thanks for watching.